Hey everyone, in this video we're going to go over our last rule with monomials, which has us working on powers of monomials. But before we start, let's review all the monomial rules we've talked about so far. So first, we've talked about adding and subtracting monomials. That's where we're simply combining like terms. So for example, in this expression where we're adding all these monomials together, the only like terms are 6x squared and 7x squared, which makes 13x squared, and then we drop down the other monomials. After we talked about adding and subtracting monomials, we talked about multiplying monomials. And to multiply two monomials, you keep their base and add their exponents. Notice that this is only for multiplying two monomials. So when you have one monomial multiplying to another, you do that by keeping the base and adding the exponents. After we multiplied monomials, then we talked about dividing monomials. Notice how this is for when you have one monomial over or divided by another monomial. So we keep the base and subtract the exponents, top minus bottom. So these are the three rules with monomials that we've covered so far. And lastly, we're going to cover powers of monomials. Powers of monomials is when you are now going to raise a monomial to a power. So we're taking a monomial and then we're going to square it or raise it to the fourth power. We use a rule called the power rule. So an example of raising a monomial to a power would be an example like number 1. Notice how we're taking 8 squared, which is a monomial. A monomial is a number, a variable, or numbers and variables multiplied. So we're taking 8 squared and we're raising it to the 5th power. This is the same as saying 8 squared times 8 squared times 8 squared times 8 squared, 1, 2, 3, 4 times 8 squared. 5 of those. That's what the exponent is telling you, that it's 5 of these multiplying to each other, which is 8 times 8 times 8 times 8 times 8 times 8. Come on, guys. Keep going. Times 8 times 8. Let's keep going. Times 8 times 8. Do we get them all? Let's see. 1, 2, 1, 2, 1, 2. Yep. Let's count how many 8s are multiplying here. That is 8 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 to the 10th. There are 10 8s multiplying, and if you take a look at that 10 and the 2 and 5, can we come up with a conclusion that this is the same as 8 to the 2, not plus 5, but times 5? So here are your options. You can write it all out this way and break it all down to here, which will take a lot of work, especially if that is a number like, let's say, 50. We don't want to do that. Or we notice that once we've done one written out, 8 squared to the 5th power, that's 5 8 squares multiplying, which breaks down even further, is going to end up being 10 8s. So we come up with this rule that's true no matter what. 8 squared raised to the 5th power is 8 to the 2 times 5, also known as 8 to the 10th. So that brings us to our power rule. Any monomial, x to the a, being raised to a power, so you've got power with a power, little guy with little guy, is the same as x to the a times b. And that's when you're taking a power, a monomial with a power, raising it to another power. So if we apply that rule to number 2, we end up with negative 15 to the 6 times 3, because here's my power and here's my other power. You might want to highlight, I recommend highly that you highlight the 2 powers raising to the 6th and then to the 3rd. And that does come out to be negative 15 raised to the 18th power. That would be a lot of negative 15s to write. With variables, if we jump over to number 9, we get k to the 4 times negative 5 power, which is equal, let me highlight those 2 powers. That's equal to k to the negative 20th power. And we know that we have to rewrite that to be 1 over k to the 20th power. So what if we have more than one letter, like in numbers 10, 11, and 12? Well, basically, that power is going to apply to all the letters. Since this whole parentheses is being raised to the 4th power, that 4th power is going to apply to both the C and to the D. So that's going to be equal to C to the 1 times 4, because the power of C is 1, and D to the 2 times 4. So we did power to power twice. Once for the C and once for the D, which gives us C to the 4th, D to the 8th power. For number 11, here's my power of 3, and it's going to apply to the M base and to the N base. So we're going to do power to power twice, M to the negative 2 times 3, and N to the 8 times 3. Notice that we did power to power twice. So that's going to be M to the negative 6, N to the 24th, which is keep n to the 24th and move m to the negative 6 downstairs to become positive. At this time, I'd like you to pause the video and try the questions that I did not do from numbers 1 through 12 and answer any questions that I ask along the way. When you have a coefficient, first of all, let's review what a coefficient is. A coefficient is a number in front of a variable. So if you have a coefficient, remember that first we must raise the coefficient to the given power, and then we'll use power to power rule. So let me show you what that means. In number 13, keep in mind that the square is applying to everybody in the parentheses, which means 3 is being raised to the power of 2, and x to the 7 is being raised to the power of 2. So that is equal to 3 to the 2nd times x to the 7 times 2, or 3 to the 2nd x to the 14th power. We could take this further to say 9x to the 14th, because this wasn't too hard to multiply in my head. So let's try number 14. 5 is inside the parentheses, so 5 is also going to get that 3rd power, and so is n to the 4th. So 5 to the 3rd, n to the 12th, because it's 4 times 3. And 5 to the 3rd I know is 125, but if you want to leave it there, you most certainly can. Now I'd like you to pause the video and try numbers 15 and 16 using 13 and 14 as a guide, and answer my questions along the way. To finish off, I'd like to do the odd problems, and then I'm going to have you do the evens on numbers 17 through 22. So starting with 17, notice that the 6th power is applying to the parentheses, which means everybody is going to get that 6th power. So that is 2 to the 6, p to the 2 times 6, and q to the 5 times 6. We had to do power to power twice for the p and the q. So that is 2 to the 6, p to the 12, q to the 30th power. Using that same knowledge, let's try number 19. Notice how that square is applying to the parentheses. So that means that 4 is also going to get that square. So that's equal to 4 to the 2nd power, c to the negative 9 times 2, d to the 2 times 2, because we're raising a power to another power and a power to another power. And when one power gets raised to another power, the powers multiply. Keep the base, multiply the exponents. So that leaves us with 16, c to the negative 18, d to the 4th. He needs to move, so we leave 16, d to the 4th, and move c to the 18th downstairs. For the last example, number 21, again, keep in mind that this negative 2 power is applying to the parentheses. So we have, that's equal to 5 to the negative 2, k to the 6 times negative 2. 5 to the negative 2 is nothing right now, and k to the negative 12. Both have negative exponents. Both the 5 and the k have negative exponents, so they're both going to move down to make 5 squared, 1 over 5 squared k to the 12, which I could easily write as 1 over 25 k to the 12. Notice how we moved both of them down because both had negative exponents. So I had to put a 1 in the place of the numerator, and I just simply wrote 5 squared as 25. Now I'd like you to pause the video and complete 18, 20, and 22, and that will be the conclusion, after you've answered the questions, that will be the conclusion of raising a monomial to a power. Keep the base, multiply the exponents. Thanks for watching.